I'll take up some algorithmic view how we handle that optimization problems. Before that, I'll float one another small scenario. Okay, if I want to say that I want to solve one real life problem, how many parameters will be there in that problem? Real life problem, and how many problem parameters will be there? Any problem you can just say it out. Yeah, number is quite large. Normally we talk about. Let us say if I want to come from Firozpur to Chandigarh, how many maximum number of path can be there? It's very large number. In between, I can go one from that street or this street or another road. Many other cities are also there in between, but I choose one, and there is some reason for that. Although that is what being done spontaneously by me or my driver, it's not an issue for us to think about that how many possibilities are there and how to go for that. But it is actually the artificial intelligence that makes us to think like this, and we solve our problems, daily routine problems. Another problem may be something like, okay, how many parameters are involved in simple cycling? I want to go for one place to another place. How many parameters are there? Those control my cycling process. 5, 6. I have to take care. No, let us start talking about. I'll have to take care of the road condition. I'll have to take care of the center of gravity. Distance I have to go. Direction, obviously, that's a part of that. And in addition to the paddling speed, how it is to be, steering, how it is to be controlled, and if brakes are required, then when to apply brakes. There are many parameters, I think. And if we want to make some kind of formula, is that possible that we can do it? Can we make some kind of formula that can be given to the computer that please, this is the formula and do cycling for me? I think it will be very difficult for us. We people are doing this without thinking much about that even. We normally talk about something else, but we don't take about. Even similar thing is with the driving also. We keep on talking to our adjacent co-passenger, those are sitting with us, and we never bother about brake lagani hai to automatically पैर दबा देगा. So that's the. There are many other. This is what is the realistic real life problems. Once we are talking of the engineering problems, these are simplified problems. We have, I think most of us might be knowing something about BJTs. We first say that temperature is not going to change. Why? Why it is not going to change? Why beta cannot change in between? Because it will affect the working of that transistor or the amplifier that we have in our under consideration where we people are working on. We freeze many parameters or ignore some parameters, those are not contributing much to the problem. And then this is how we reduce the number of parameters. Then with the reduced number of parameters, we make some assumptions that, okay, transistor is not a linear device, but it will behave linear within this region. Further simplification of that problem so that I can apply Ohm's law. Otherwise, I don't have the formulas to handle non-linear devices. Then we make H model or pi model. Then we think about that. Okay. Then this is what is the way. How do we handle engineering problems? But if I say that no, I have to solve problem, whatever the realistic real life problems or the constraints are there have to be taken care of. Then it becomes very difficult. The parameter number becomes very large. Okay, another feature, whatever we refer to, say the traditional mathematics that we use to handle this kind of problem can support only 3-4 parameters. I think we have undergone the course of partial differential equations to handle multiple parameters. We make one silent and speak another. What is the difference? Then we aggregate them. Then we get it. Something like सुपरपोजिशन वाला जो कॉन्सेप्ट है, इट्स द सेम थिंग इज अप्लाइड देयर. Then we can handle some parameter, but still differential equation of the order of more than 3 or 4, then it will be a problem. Will not be able to handle. Parameter number can increase, that we have already talked about. Then how to handle that kind of problems? Because presently, if we say that computer can do all calculation for you, but it has to be taught what method has to be followed. This is what is the bottleneck problem. There we have to, okay, we can solve to some extent. There are many mathematics people, those are working in handling this kind of problem. They are taking it as a research issue. Okay, I'll be able to handle that. With some of the other mechanism, maybe taking more time, maybe having requirement of more computational power, I'll be able to handle that problem. But is that my objective? My objective to have an approximate solution. I'm not required to have very precise solution. Isn't so? Okay, to appreciate this concept, let us say that I came from Firozpur to Chandigarh. How much time it should be taking? 4-5 hours. Is there any person who is going to say that 4 hours, 30 minutes, and 25 seconds? Isn't so? We are always requiring approximate answer to our problems. We don't want it to be very precise. It's all useless. We do not interpret numbers, but definitely to some extent it conveys the idea that this is the approximate number and you can make some decision. Okay, if I talk about that, how is the personality of this person? Okay, if I take one parameter of a personality, dressing कैसी है? Okay, I'll talk about this how the dressing is. You'll say, okay, it's good. Okay, I'll say that, ठीक है, I'll understand what this good means. That is what the concept of fuzzy logic. और जब हम कभी आज ठंड है थोड़ी, अगर मैं लेट अस से कि रास्ते में कहीं रुक करके चाय पीना चाहूँ, तो मैं उसको क्या बोलूँगा? गरम गरम चाय दे दो. Isn't so? I won't say 80 degrees Celsius. Or I need a tea of maybe 150 grams of milliliters. We don't talk about that type of numbers all the time. We say 1 cup and garam garam. That we understand, and we make decisions also that this is okay, this is not okay. What ठंडी हो गई है चाय. That is the linguistic way. How do we handle our real life scenarios? And we want a computer to do that for us. I should be reaching my destination. I'll be solving my problem, but not with very precise solution. It's not that demand. That's why the concept of approximate computing or the soft computing techniques came into existence. Okay, I think this is something that is very much important. Now we'll be talking about the algorithms. Those can give me solutions, or those can help me in identifying the solutions from thousands of solutions. Thousands or maybe sometimes lakhs of solutions I'll be having, and I'll be able to identify that this solution is very suitable for me. Okay, so this is what the demand of us also, that time is limited, that I have 1 day and my problem is to be solved. I have a solution of let us say total in number 1 lakh. One solution can be evaluated in, let's say, 1 hour. Then how many hours I will be requiring? 1 lakh, approximately 1 lakh hours I will be requiring. But my objective is to identify one solution within a day. Now how it can be done? Okay, so that is the task of this optimization. We'll be optimizing the solutions, or we'll be having rather from 1 lakh solution, I'll be picking up say 10 or 20 solutions randomly and then mixing them in such a way that they'll evolve as a one best solution. They'll evolve themselves as a one best solution. This is why it is sometimes called as a swarm intelligence, because we are having a swarm of solutions. It's a crowd, it's a group of solutions. Those work collectively to give me some solution, and that's what uh, is the modern, we call sometimes, heuristics that we take into the programming part. Heuristics is something with the common sense or the natural concepts that we see in our nature. How do we behave, our system, our social system features. We try to copy them into computer programming. That's why computer programming is separate. That's why I talked about that. If you are comfortable with computer MATLAB programming, then I'll be talking about the logics. Then how the logic works, then you can code it into the form of some computer program and solve your problem of your domain. I'll be talking generic things. Okay. Uh, this is the basics of the need of heuristics. Why we need heuristics to be taken care of for solving our problems. Genetic algorithm is one of the very popular, and still I'll say it is having some features those are not available in many other optimization algorithm. Although there are more than I think 15 or 20 optimization algorithms available in the market, and we are also working on one of the algorithm, and results are good, but um, my objective is not to talk about that, but there are many objectives optimization functions or the optimization algorithms. Those can be used. Genetic algorithm is one that has some features those are not available in other optimization algorithms. I'll talk about that sometime. Then particle swarm optimization, another very popular optimization algorithm. I'll take up some examples with this. It's having now you can say whatever the particle swarm optimization algorithm or the technique has some inbuilt qualities are being copied in most of the optimization algorithms. That's why I have taken over here. And then I'll try to show with some MATLAB demonstration that how they are actually working. Maybe if time permits, I'll try to show you the code also. Otherwise, this code is available on the website that I have. It's drsatvi.in. Okay, you can download it from there. The Firefly algorithm, we are working in modification of that, and I'll talk about something that this algorithm is giving a bit comparatively better results. Or because once we people are into research, we want to show our results in a better way, and we want to have definitely in all these algorithms you'll have to tune your parameters. Strategy parameters has to be tuned first, then only you'll be getting your results. It doesn't mean that every algorithm works equivalently good in all the application. Depends upon your parameter tuning. If you tune your parameter in such a way that suits your application, you will be getting better results with the one algorithm may not be suitably available from the other algorithm. You'll have to take care of that. That once you check one algorithm for your application, and you'll have to be very carefully decide the strategy parameters also. That we'll talk about. Real life problems we have talked about is highly complex. जैसे एक मैं अपने स्टूडेंट्स को और एग्जांपल देता हूँ कि भाई मैंने आज एक कटोरी दलिया खाया है एंड आज मैं कितना टाइम बोल सकूंगा कैन वी हैव सम काइंड ऑफ फॉर्मूला फॉर दैट इट्स अ हाईली कॉम्प्लेक्स मैकेनिज्म आई डोंट नो वो कहाँ गया एंड वो कितनी एनर्जी प्रोड्यूस करेगा एंड इट्स नॉट पॉसिबल दैट आई कैन मेक सम काइंड ऑफ फॉर्मूला हाउ लॉन्ग आई कैन टॉक नाउ and this is not possible to make some formula. It's highly complex, it's highly non-linear also, large number of parameters involved, and bigger thing is that I cannot express in the form of mathematics. If even I have parameters also, it cannot be, so that I can write a program. भाई आज आपने इतना खाया तो आज तो ये तो लेबर वाला बहुत बढ़िया तरीके से यूज करता नहीं तो इसको Okay, so this is what is the nature of the real life problems. Okay, then engineering problems are simplified. I talked about I want to design some kind of amplifier, I'll have to take care of that. BJT is not a linear system, but it can behave a linear device within some constraints. Once you make some kind of biasing, you make temperature constant, you make beta the uh, current gain of a transistor constant for some time, then you can make some approximate calculation. Whatever the calculation at the end of the all that process, you will be getting an approximate gain of the amplifier. That this is the gain that should be getting. Okay, this is the simplified way that is very popular among electronics people. That's why I've just raised that. Uh, Okay, there are some nowadays some softwares available in the market. Those are based on empirical formulas. Empirical formula, we have some formula, but we don't have derivation for that. But it is working. VLSI design and ORCAD and some other computer design tools are using these empirical formulas. Those are giving us practical results. They are taking care of all the parameters, but there is no derivation for that. That is the issue. Because in engineering we say that whatever problem can be solved using mathematics is only engineering problem sometimes, but now it is not the scenario. You can have a mathematics without its background support, and but it should be solvable, it should give you result. If it is working, then it's okay. uh, Whatever the things that we have, we humans have, we want that it should be available with the computer also. For example, large knowledge base. We are having small brain, but a lot of knowledge is there, and it keeps on accumulating and keeps on refining also. And that's what is actually containing all the things, that how the things happen in the world. I know that this phone can ring anytime. Hmm? I have that idea, and if it is done like this, then what to do? Now, how to behave in that case? How do we communicate with among people? And even now, some people are interested in talking to or training to the animals also. That's what is possible from the knowledge network, knowledge that we have. We have ability to adapt to right in the perspective where we are now interacting with. Let us say if I say that the temperature is about 1500 degrees Celsius, so it cannot be a temperature of a body. It can be a temperature of a furnace. We know that. We can interpret that किसके बारे में हम बात कर रहे हैं. So this is what is the things that we humans have. We want it should be available with the computers. Okay, they should be able to perceive, recognize, understand with the real world problems. They should be able to give reasoning. That's the another issue. Look, we are given a scenario. From that scenario, we should be able to extract some knowledge, and based on that knowledge, we can have some crystalline form of knowledge that can be used for handling some other problems. Okay, that's what human can do, but at present it's not possible with the computer. But artificial intelligence people they are working on this scenario that we want to make robots so those can behave like humans. Okay, so that's the requirement that we want. Okay, how these objectives can be achieved? The issue that we want that computer should be able to do this for us. How? What are the tools? What are the techniques? That's the soft computing. Soft computing is a one. Many people may say it is artificial intelligence, soft computing, approximate computing, may some other terminology you can talk about. Lekin, if I say that these are the three main pillars of, you can say, the artificial intelligence. It's fuzzy logic, how human interact with each other and interpret knowledge. They can handle uncertainty in the variables, and even then we can make decisions. We do it. We do it unknowingly. I know that how whenever we face some kind of interview, I know I am asked some question during Viva exam. I'm asked, or I'll ask some question. Based on the answer, I'll be trying to interpret how much the knowledge the person is having. Then we make numbers also. In case of interview, we choose or we not choose. If this person is suitable for my institution or my organization or not, that is only based upon the answer that you give. And various type of questions are asked depending upon the scenario. Sometimes technical questions are asked, sometimes HR questions are asked, personality related questions are, stability related questions, that person will be stable or not. We try to extract knowledge from these question answers. Then we interpret into some making some kind of decision making. Okay, this is what is the concept of fuzzy logic. I'll not go into much detail of that. I think there will be some special lecture on that topic, how the fuzzy logic is. Then neural networks, humans have small brain, but it is, if you go into that, there are about 100 billion neurons in a brain, and every neuron is connected to almost 1,000 other neurons. The network is quite large. 100 billion, 1,000 connection of one, about 10 raised to power 15 neuron connections are there. And although we try to make into the computer terminology, computer processors are being into the, research. The people are working on creating some kind of artificial brain, but it is still in research. We want to have that type of, and this is a network that trains, that requires some training mechanism. Then you can use it. Once we people were like kids, so we were not able to walk. Then we learned that. After that, our body adapts to that. We don't learn again and again how to walk. Daily morning, we do not do it again. That morning में सवेरे उठे और फिर चलना सीखना शुरू करेंगे फिर दोपहर तक. So it's done only one time and it is then in use. So that's a very good paradigm, that if we can make computers to learn in such a way how humans are doing, then it's going to be a big contribution towards getting intelligent systems. Okay, then the evolutionary algorithm, that the thing, the optimization algorithm I'm supposed to talk about. This is also once the nature is established itself, and now it is very robust. We human people have behavior that evolve daily. अगर मेरे को कोई कहता नहीं आज कुछ ऊंची आवाज में कुछ बोलेगा तो मैं उससे बात करते समय अगली बार सोचूंगा, ध्यान रखूंगा कि हाउ टू टॉक टू दिस पर्सन, इसका टेम्परामेंट कैसा है ना. We learn that, then we use it, and we learn it from social learning also. We have some learning is spontaneous within the system, in my own system, some learning from my parents also. That's a genetic learning. Whatever the features of my parents are there, if they were very intelligent, then some feature may be coming into me also. And this is what is the genetic improvement in the learning. The another is my society. Let us say if there is a class of 50 students, then one student can learn from another student also. One student is performing very good, is giving 6 hours daily for studies and 1 hour for playing games and 1 hour for just other things and friend circle, and this is how he has planned his, let us say, daily routine activities. Another student can learn a similar way. I'll take another small example. During my BTech studies, I have been passed from a government school, but once I go into college, there were people, those are from having very good background, their style of studies were very different. Once I interacted with them, then I came to know this is another way that can be followed for studies, and I try to adapt that. Then obviously improvements was visible. This is called social learning. We learn from each other. If you, let us say, for in a crowd, you forget your path, where you are, where you should go. Let us say in a city, you get lost somehow. The easier method is to follow that path where most of the people are going, and they'll be definitely going towards some kind of main highway sort of, and you can get out of that problem. This is a social learning. If you feel sometimes, this is the way how you can. Okay, then there are many other algorithms. Birds also have their, ants also have some mechanism. They remain in a group. Honeybees also remain in groups. So these are some algorithms developed from these concepts. I'll just give some names of that. Then I'll come to the problem of genetic algorithm, that how the algorithm actually works. Genetic algorithm, the whatever the features of parents are there, these are copied into the kids, and this is how the optimization may occur. You know that our parents were having one lifestyle, we are having some lifestyle, and we can expect that our kids will have even better lifestyle than us. Whatever their features are there, they are better than us. We had the features, those are better than our parents, and we are improving genetically also. This is the concept is to be mimicked in the form of algorithm to solve our engineering problems. Okay, biogeography based optimization. We know that birds fly in a flock, and they also migrate from one place to another. Where we are copying the concept of bird flock, it's called particle swarm optimization, where we consider their migration from one place to another place. That's called biogeography based optimization. These are two different learning mechanisms, you can say. Those are copied into optimization problems. Bacteria is also very intelligent. Otherwise, bacteria is not suitable for us. We always take antibiotics, but their intelligence is something that they change their path. Once they see some kind, they sense. They are having also sensing mechanism. Once they sense the antibacterial medicine is injected into the body, they change their path. In a such a way, they can get away from the antibiotics as long as possible. That's why it is said that अगर आपने antibiotics ले रहे हैं, take full course of that. Otherwise, it will become more rigorous, and you'll be in big trouble. So that is the thing that has happened with that. यहाँ पे हम लोग इसको दूसरे तरीके से सोचेंगे. We'll be talking that they have some intelligence. Their intelligence is to be mimicked algorithmically to solve our engineering problems. That is the way. Okay. Then mimetic algorithm, genetic plus PSO. Once we combine them together, we call it mimetic algorithm. Some genetical learning, some social learning. Just like human people, we always don't have all the features from our parents. Also, we have some learning from our friend circles, some neighborhoods. Then we are supposed to be one person who can survive in the world, and that is the overall mimetic algorithm. Artificial bee colony, another paradigm. This is something like how honeybees are working. Once they are in a group, we cannot dare to touch them, but they have some features. Those can be copied in optimization algorithm. Cuckoo search is another one algorithm. There are about 17, 18 algorithms available till date. But now I think the number may increase. Now the question is coming up, why you are giving another algorithm? That is also how it is better than others, whether it is applicable to every application or not, whether it is giving best result in all the application types of applications. That is what is the demand now. Okay. Then artificial immune system, how our system, once we are getting attacked from some kind of a virus or a bacteria, our body starts heating itself. Can we have a system like this that कि भाई मेरे कंप्यूटर के ऊपर अगर कोई अटैक वायरस का हो रहा है तो वो भी अपने आप को स्पॉन्टेनियसली रिएक्ट करे कि भाई नहीं मेरे को इसको खत्म करना है या इट शुड नॉट सर्वाइव. तो मैं अगर ऐसा कॉन्सेप्ट अगर सर्वर के ऊपर लगा लूँ, आई थिंक नेटवर्क के ऊपर लगा लूँ, आई थिंक वी कैन हैव better system. Okay, that is another way of optimizing the system. Firefly, Firefly and glowworm swarm optimization. These are two different algorithms inspired from one insect. You know, जुगनू जिसको हम बोलते हैं. So it is inspired. One insect inspired two different scientists at the same time, but different mathematical background. No, it was reported, I think, in the same journal also, but two different scientists have done this thing. One was Indian from IIC Bangalore, the another person was from US. So they evolved with the same idea that how these fireflies interact with each other, can we use it for optimization, and they are given very good results. That's why I have taken into this discussion also that their performance is quite good. Even we have identified some scope that it is still possible that you can improve, make some kind of improvements. Wound healing, this was the one algorithm that we started working on, but not succeeded much. But it is one, you know, that whenever we get some kind of wound on our body, it automatically repair itself. How it happens, how human system is designed to be. Can we learn something from that? I accept that I could not model it that good. That could be, I think, and even maybe you can take it as your search area. Yeah. Otherwise, if you say that how to check that whether they are applicable to optimization area or not, there are some set of benchmark functions. Whenever you design some optimization function, it has to be tested on these benchmark functions. Once they perform there, then you can apply on your domain area. Okay. All these algorithms were tested on a benchmark function. There are about 30, maximum 30 optimization mathematical functions are there, and every test results have been presented. Whichever is performing better on all these test functions are supposed to be better as compared to others, and then only we choose that. Okay, my problem is like this, and this is suitable to this. This seems to be similar to one or two optimization function. Then you can choose that this algorithm is suitable to my application. Okay, I'll give some idea कि वो function दिखते कैसे हैं. I have lots of some functions, not all, but few function will give you an idea that how they look to be.
I am inspired by something. Is it like I have to develop a mathematical modeling of that? Because that is the first thing. Or we have to go and study that biologically. If it is GA also, what was the base? How did they find? Like we don't know about the body condition, all those things. So we have to go study that, like how the chromosomes and all those things are working. And then should we develop the mathematical modeling for that?
Okay, I think you have some idea about genetic algorithm. There is string, and we know that strings get twisted to at some places, and how it is to be done. If it is possible to be done with the mathematics, then do it with mathematics. Okay, if it is not possible with mathematics, it is possible to be done in a form of algorithm, then do it with the algorithm. Mathematics is a supportive. You are actually mimicking some biological process. Okay, whether you do it mathematically or you do it with pseudocode, then it's not a problem. It's not an issue. But you can have one-to-one relation with the biological and artificial model. Artificial model can be anything. Maybe mathematics, maybe non-mathematics. First, mathematics is supposed to be better because computers are meant for that calculation purpose. Otherwise, algorithms are also possible, but it takes some time. It is process. Lakhs of papers have been published on fuzzy logic. Type 2 fuzzy logic, it's a bit new, but not that new. Even about 20,000 have been published. This is the data given 2014. Neural networks, evolutionary algorithms, genetic algorithm, particle swarm optimization. These are some keywords searched on Google Scholar. Then I can see that how many papers are there. Um, okay, let us start with the genetic algorithm. Okay, before starting with the genetic algorithm, what do you feel about these kids? क्या इन सबके पेरेंट्स एक ही होंगे? हाँ? yeah, that is the genetic algorithm. That's it. अगर आपने ये चीज को समझ लेते हो तो you can appreciate the concept of genetic algorithm. Okay. Otherwise it is based on the survival of the fittest. अगर हम अभी तो ह्यूमन के ऊपर का इतना एप्लीकेबल नहीं है, लेकिन अगर मैं कहें कि भी नेचर इज समथिंग लाइक दिस कि the concept is survival of the fittest, Darwinian theory. There are some processes into this genetic algorithm. Those are actually mimicking natural system. Selection of parents, one, where we choose parents to create next generation. And then next process is crossover. They produce next generation and their genes get mixed. You know, अगर किसी के मतलब फादर की या मदर की आईज का कलर ब्राउन है या कुछ और है, तो मोस्ट लाइकली इट इज टू बी कैरिड टू द किड्स आल्सो. This is one example of gene forwarding to the next generation. Okay, then this crossover, here I'll be talking of single point crossover. It may be multi-point crossover. There is some variant also. That there are many features. Is there any query? Okay. There are many features. We are still in the process of decoding of human gene, or how they can be. They'll be contributing towards the new generations. So this is what is the just an idea that we will be making this logic also. Okay. Then the some features are there into the kid, those are their own. It's not from even parents. What is the break time? Okay. Okay, there are some features in the kids, those are not coming from their parents. That is also possible. This is the process, is called mutation. We'll be doing the same thing in algorithm form also. Okay, and this is just a flow. How, if we talk about the computer, how computer can work, it is to have some kind of flow. Okay, first we'll start with the creating a random population. Random chromosomes will be there. I'll be having system parameter encoded in the form of a string. String is something the parameter. Okay, let's take some real life problem. Mm, okay, I'll take this one. This is one pen. What should be the length of this so that it should be comfortably? What should be the width of this? How much ink is to be poured into this so that it can last at least for 1 month, or it will require one clip also, or some other color for attracting the envelope. Okay, so these are some parameters. Those are going to be a design parameter of this pen. Okay, I'll say this is x1, this is, say, color is x2, length is x3, diameter is x4, and something like this. So these are 5, 6, 10 parameters of this pen. This is encoded in the form of an array. Okay, this is called string encoding of this design. Okay, how many parameter, how many possibilities are there? No, let us say length cannot be less than 10 mm, sorry, 10 centimeter, and cannot be more than 20 mm. So this is the universe of discourse for the length. How much resolution you want? 1 mm, 1 centimeter. So it depends upon your problem. Okay. So depending upon, let us say if I say that it is 10 centimeter to 20 centimeter and the resolution is 1 mm, so there is 100 possible values for this, isn't so? Similarly, the diameter is also going to be, we cannot make it a pen like this size, so we'll have to have some parameter. Universe of the scores for this pen will be there for every parameter, x1, x2, x3, x4, whatever. Okay, within that range, I'll pick up some random number. Initially, very first stage is that I'll take up all these parameter values within that range randomly. I don't know if there is any relation or not. Okay, this is what is called string encoding of this design. Done. Okay, the next is the next starting parameter is fitness function. Now this pen is meant for something, what? Writing, comfortable writing rather than only writing. कि भाई मैं इतने मोटे पेन से भी लिख सकता हूँ, लेकिन it's not going to be comfortable. Okay, so it is to be a comfortable writing. Maybe some other parameter कि भी इसका फ्लो बहुत अच्छा होना चाहिए, इसकी जो लेंथ है वो बहुत मतलब बढ़िया होनी चाहिए, या कुछ ऐसा कुछ पैरामीटर, इट शुड बी पॉसिबल कि भी मैं इसको पॉकेट में रख सकूं. तो देयर मे बी मल्टीपल ऑब्जेक्टिव, बट हियर आई एम टॉकिंग ऑफ सिंगल ऑब्जेक्टिव that is going to give me the quality of that particular design. फिटनेस वैल्यू या इवैल्यूएशन मैं कहूँ कि भी इस डिजाइन की इवैल्यूएशन करनी है. Okay, so this is called fitness function. I think you can relate with your domain area. Wherever you are working, you are designing some kind of motor, you are designing some kind of switch, you are designing some kind of amplifier, whatever the thing in your area, you might be working on some kind of design. Whatever the design parameters are there, it is to be encoded in a form of string that we call it chromosome, and the fitness function that is going to be evaluated. Okay, randomly I have taken some values. Let us say I'll be taking these string values for 20 times, 20 different designs based on random inputs, and now I can evaluate them all, isn't so? Based on the fitness function, that they all can be evaluated. And this is called initial generation mechanism. Then evaluate their fitness and rank them. I think there are 20 solutions for one problem. If you compare them, you'll find one best, isn't so? And other may be graded accordingly. One poorest, one best, other will be in between somehow. Then we make selection. Okay, selection is to be process whichever design is giving me better performance or evaluation results. I'll pick up that. ये नेचर में कैसे होता है कि जो सर्वाइवल जो फिटेस्ट हैं दे गॉट अपॉर्चुनिटी ऑफ मीटिंग. तो ये जो कॉन्सेप्ट है ये हमें हमने सिलेक्शन में लेके आना है. कैसे करेंगे कि विच एवर इज हैविंग बेटर फिटनेस, जिसकी जो वैल्यूएशन फंक्शन जो है वो ज़्यादा फिट है, परफॉर्मेंस जिसकी ज़्यादा अच्छी आ रही है, आई टेक अप दैट वन एंड गिव इट प्रोबेबिलिटी सम काइंड ऑफ कि बेस्ड ऑन दैट प्रोबेबिलिटी इट विल बी सिलेक्टेड और not selected for the next generation to be parent. Okay, this is the process of selection. I'll go into that, how it is actually done in the form of algorithm. The next step is to create crossover. I'll be selecting two parents randomly based on the probability of their selection that is linked with the fitness value. Then cross over them at maybe multi-point or maybe single point. Mix their genes, whatever the features are. मैंने L1 parent 1 की रखी थी वो कॉपी करके मैंने parent 2 में कर दिया और parent 2 की जो कॉपी जीन्स थे वो मैंने ऊपर कॉपी कर दिए और ट्विस्ट कर दिया. Okay, this is called crossover. Then mutation, some from the whole population. 20 solution थे मेरे पास जो नए अब जनरेशन मेरे पास क्रिएट हुई हैं, दो पेरेंट से दो ऑफस्प्रिंग जो बनी हैं. And I'll be picking some random feature values and modify something to some extent. Not exactly all. सारी की सारी चेंज नहीं करनी. पूरी पॉपुलेशन में से हम नॉर्मली 1% या 2% ही करते हैं. It's not done that frequently. Okay, then this is how we get a new generation. This is the last step of this iteration. Sometimes at reaching, while we will be reaching here, we'll be losing our best solution. जो पूरी स्वाम के अंदर 20 स्वाम में थे वो हो सकता है कुछ खराब हो जाए क्योंकि मिक्सिंग करी ना हमने. तो सम सोल्यूशन में गेट लॉस्ट इनटू दैट. टू अवॉइड दैट वी टेक अप इलाइट सोल्यूशन. वी इंट्रोड्यूस अ लाइट सोल्यूशन. जो पहली पॉपुलेशन में स्टार्टिंग में थे उसमें जो बेस्ट सोल्यूशन थे, अगर वो खराब हो गए हैं तो वापस डाल दो पूरी स्वाम के अंदर से. उसमें से जो वर्स्ट है उसको बाहर निकाल करके नया वाला उसकी जगह पर डाल दिया. दिस इज एक्चुअली इलाइटिज्म. ताकि ये एक्चुअली कि आर्टिफिशियल इंटेलिजेंस में हम मॉडल इंटेंशनली करते हैं. आई डोंट नो कि वेदर देयर इज सम बायोलॉजिकल सिस्टम आल्सो और नॉट, बट वी मेक इट लाइक दिस. ओके, तो ये इंटेंशनली जो हम लाइट कॉन्सेप्ट प्रिजर्व करने के लिए हैं कि बेस्ट सोल्यूशन शुड नॉट गेट लॉस्ट ड्यूरिंग दिस प्रोसेस ऑफ क्रॉस ओवर म्यूटेशन. ओके, and then we check whether we have achieved our target value or not. That we want that this design should be like this. There will be some parameter to make that this is the best design I'll be having. Sometimes we do not have that value even. We just want to have maximum value. You know, let us say कि भाई मैं profit making mechanism design करना चाहता हूँ. मैं शेयर मार्केट के लिए कुछ इन्वेस्टमेंट करना चाहता हूँ. लेट अस से कि देयर आर 20-30 कंपनीज. तो मैं कंपनी 1 में, कंपनी 2, कंपनी 3 में X1, X2, X3, X4 मतलब ऐसे करके मैं एक स्ट्रिंग बना ली कि इस कंपनी में कितना इन्वेस्ट करूँ ताकि मेरे को मैक्सिमम प्रॉफिट मिले. लेट अस से द प्रॉफिट मेकिंग हियर इट इज द फिटनेस फंक्शन. आई डोंट नो, आई डोंट हैव एनी टारगेट. आई वांट मैक्सिमम ओनली. हाउ मच मैक्सिमम इट कैन बी. दिस इज व्हाट इज द टारगेट. I don't have the value that it will be reaching maximum 100 rupees the profit. I can't say that. But this is just an optimization problem that I want to maximize my profit. Sometimes it may be a minimum also. That let us say I want to make some kind of minimization problem. In that case also we will be having some minimum value. Or otherwise you can say that if there is no improvement in the best solution for 100 iteration, then stop it. This is another way to terminate your loop. Otherwise, this is infinity loop. Either you have reached your target, or you are in a process of infinity and there is no improvement in the best solution, then terminate it. That is another way. How do we do it? Otherwise, you can say that, okay, I'll be running 100 iteration, या 1000 iteration, then I'll terminate. I don't know कि भाई वो कितना improve हुआ या नहीं हुआ. I'm not bothered about. मेरे को 100 iteration के बाद में जो best solution मिलेगा, I'll take it. There may be some other parameter or the other mechanism to terminate this loop. Okay, this is the actually flow of the genetic algorithm. In I think computer की जो थोड़ी सी terminology की बात मैं कर रहा हूँ तो ठीक है. Now I'll go into the details of this selection process and crossover implementation.
Every time we like candidate करना है और when it is not like when the जो new parent है, if they are fit parents, then वो elect करने की जरूरत नहीं है. If you feel कि
हाँ, otherwise no, it is not required in that case. If you are losing your best solution, in that case,
conditional box
yeah, definitely it can.
There should be a decision box.
Yeah.
If it is required, then elect आना चाहिए. Otherwise,
Fitness evaluation, actually fitness evaluation, it is to be done again over here.
Yeah.
Actually, this is next generation default. I am taking that this is there into that part. Otherwise, without fitness evaluation will not be. Yeah. Two steps combined into next generation. It's a part of that. Obviously, it has to be there. We'll be just taking that step in case we are losing our best solution. That's the objective. This is what is the parameters that I was talked about, how to create a chromosome. I've taken one example of pen design, or you can have another example of market share, market investment into companies, how much amount you want to invest into one company. There may be 10 companies, 20 companies corresponding to that. You can decide that X1, X2, X3 till X20 will be the amount that is going to the respective companies. So that may be the optimization, another optimization problem. Okay, so this is how we encode one solution. This is tentatively one solution that is formulated in the form of array. Okay. Okay, let's take another simple iteration. I'll say that there are 6 chromosomes. Okay. And some having some range values. Say gene 1 is having a range value from 0 to 9, 2 is 2 to 7, and third is having 1 to 5, and something. Let's say I have taken some random values for all these chromosomes. Now this is one chromosome. Okay, and if I add them all, it's going to be 32. Let's say it's a profit making some kind of profit key values जो मेरे को result मिल रहा है वापस. I'm not talking about. This is the fitness function. Just simplicity के लिए मैं आपके साथ में लेके चल रहा हूँ. This is simplicity. It's the idea that whatever the resultant summation is there, it's taken as a fitness function. It can be some formula also, further formula, a complex formula, but here it is just an idea how it actually going to work in form of variables, and earlier it was flowchart. Now variables and the functions, how they are going to be. Okay, now I think we can appreciate that there are 35. This is the best solution. Then 32, 28, 21, 24, 21, 22. Okay. Now I'll divide that into pie chart. Let's say the area is 100, and area is corresponding to their contribution. Their contribution is going to be the corresponding to the fitness value. What I have done, just added them all. Once I have calculated the percentage of that total, there are, if I add them all, I'll be getting some number. If I divide that every number with that number, total sum, I'll be getting percentage. Okay, this is what is that. 1 to 6, total chromosome, then percentage area, and that percentage area is now shown over as a pie chart. Okay, get that point? It's simple. Actually, I got to select parents for the next generation. For that, I have to have a mechanism like this, that who is having better fitness value should be able to proceed to the next generation. But it is not all the time. It is not all the time. Sometimes weaker solution also get a chance of getting into the parent pool for the next generation. Okay, this is why it is taken as a, based on this pie chart, a wheel is prepared and then rotated at a random force. Okay, and one marker given at the lower side, one marker, whatever the segment is coming into, that will be part of the next parent pool, next generation parent pool. I think now we can have that idea. Probability, fitness value, and possibility of selection is in one line. If the fitness value is more, probability of selection is more. But it is not like this that the poorest will not be selected. Maybe selected there. Chances are less. Okay, so this is actually the concept of natural phenomena. Okay. Now, then we randomly make groups. It will be better that if having more fitness and in one group parent pool, then solution corresponding to their offspring will be better. Okay, now this is what is just randomly I picked up and made a parent 1, parent 2, parent 3, parent 4, and grouped them into 2. Now there will be crossover. Before that, I'll have to generate some random numbers. These random numbers will be nothing but the points of crossover. This is single point crossover. Simple idea, single point crossover. एक और क्वेश्चन होता है कि क्रॉसओवर करना है या नहीं करना. That is also one issue. 90% 95% से 99 के बीच में हम रखते हैं इस नंबर को. This is going to be a crossover. This is going to be crossover. कि crossover करना ही नहीं है या नहीं करना है या नहीं करना है. That is also to be decided. अगर करना है तो किस पॉइंट पे? तो स्ट्रिंग की लेंथ कितनी है, उसके बीच में एक रैंडम नंबर, इंटीजर नंबर को भी जनरेट कर लीजिए. एंड आफ्टर दैट यू मेक ट्विस्ट इनटू दैट. ऊपर वाले शिफ्ट कर दिए नीचे और नीचे वाले ऊपर. इट्स अ ट्विस्ट एट दैट पॉइंट ओनली. इसी पॉइंट के ऊपर ट्विस्ट कर दिया. दिस इज कॉल्ड क्रॉसओवर. सिंगल पॉइंट क्रॉसओवर. मल्टी पॉइंट भी कर सकते हो, यूनिफॉर्म भी कर सकते हो. ये हर एक पॉइंट के ऊपर आप डिसाइड करो कि क्रॉसओवर करना है या नहीं करना. Create a bit of let's say there are कितने, string length is 8. To create 8 binary numbers. First binary number is, if it is 1, then make crossover. Second, if it is 0, don't make crossover. If it is 0 again, don't make crossover. If it is 1, then make crossover for one bit only. This is called uniform crossover. There are a variety of crossovers. मार्केट में आप थोड़ा सा लिटरेचर सर्वे करोगे, you'll be getting lots of varieties on crossovers only. Single point, multi point is most popular depending on your problem. Now this is what is the strategy parameter. Once you take up your problem, I was talking in the initial stage of this discussion that once you choose one algorithm for your problem, you'll have to carefully decide what is going to be the strategy parameters. सिंगल पॉइंट क्रॉसओवर होगा, मल्टी पॉइंट होगा, कितने पॉइंट रखने हैं, या आप चाहते हो कि इस पॉइंट को तो करना ही करना है. यू कैन फोर्स ऑल्सो डिपेंडिंग ऑन योर रिक्वायरमेंट इफ यू फील लाइक दैट. ओके, दिस इज द concept of crossover. Now getting genes mixed, and this is the, no, it's not actually the parent, now it is children. Child 1, child 2, child 3, child 4, child 5. You take it like this is not now parent. But actually, once we make a small change, let's say this was supposed to be gray, but now it is modified. Why modified? new feature added into that that is not available in the parents. This is actually the process of exploration. Exploration and exploitation are two important feature of every algorithm. Every optimization algorithm must have two features. One is exploitation. Whatever the feature values you have, you just make all the combinations. And that combination should be experimental in such a way that you should get your results at the earliest possible. This is exploiting all these features. Then exploration, some new feature values, those are not existing into this. Okay, so this is how you can experiment this thing. Mutation is creating some new feature values, those are not existing. Now next time this will be a part of this. This is the new generation. This is now the child 1 to 6. Okay, so next time you will be having one feature that is new to this kid, this kid, and this kid. Okay, this is called mutation. Some features of the kids itself that is not that was not present in the parent pool. Okay, so this is the concept of. Now this process is to be repeated once again. Now this is going to be the next generation. Now this next generation will act as a parent pool for next iteration. You know, human beings are on earth for a long years, and this process is improving and still improving. And this is what is the scenario that हमारा जो लाइफस्टाइल है, जहाँ हमारे पास जो इंफ्रास्ट्रक्चर है, जहाँ हमारे पास जो अंडरस्टैंडिंग मैकेनिज्म है, जहाँ लर्निंग एटीट्यूड है, जहाँ मैकेनिज्म है, दिस इज इवॉल्व्ड ओवर years. Now how to mimic this is what is discussed here into the form of algorithm. Now this algorithm can be used for solving our engineering problems, because computer can iterate this process within seconds, maybe sometimes fractions of seconds, and this process 100 iterations, 1000 iterations, you can do it on a computer within a minute, and your solution will be available, isn't so? Let us take one example. Traveling salesman. It's a very popular, it's one of the benchmark functions now, you can call it. Its scenario is something like that. The one salesperson has to travel, let's say, 10 nodes. Objective is to find out the minimum total distance should be minimum in to identify one path where the total traveled distance should be minimum. Obviously, time will take should be minimum. Some people have investigated the same problem, that giving a path value also, that this is a costly path and this is a cheaper path but long, and corresponding, you know, some alteration, some modification, people have, you know, experimented on that also. But for the simplicity, for single objective, you can take only one parameter, that the distance is only one significant parameter that is going to contribute. Otherwise, you can make it multi-objective or multi-constraint parameter. That's what is possible. One node is to be traveled only one time. Okay. Okay. I'll take you to the MATLAB environment after this GA. Okay. I think let's take only 4. How GA will solve that? It will travel all these nodes and will identify this one. Let's say I'll add some more. Sorry, I have to stop. This iteration process keep on going. You can choose location of the nodes, and then whichever the best path will be highlighted. This is happening in a very small time, you know. मैं एक क्लिक करता हूँ, साथ के साथ रिजल्ट आ जाता है, because computer is not taking much time to handle this is small number. If it would have been 1000 dots, I think it will take a lot of time, but मैं कोशिश करता हूँ कि भाई sufficient सा number आपको दिखा दूँ. It's taking bit time more as compared to the previous case. It will identify all the paths. This same problem has been solved using ACO also, ant colony optimization. That ant colony optimization is very popular in what do you say, uh, movement of packets from source to destination. We want to identify a path where the delay is minimum, and that is applied into the networking also. Okay, this is what is the experimentation. Now you can see how actually it runs. It is all experimenting, making permutation combinations so that all the nodes should be traveled, and ultimately constraint is there that every node has to be traveled only one time. Okay, so this is the way how. Otherwise, can you imagine how many कितने नोड्स यहाँ पे शायद मुश्किल होगा. लेट्स से कि 25 नोड हैं. 25 नोड अगर हैं तो how many possibilities are there? How many possible routes can be there with the constraint that every node will be traveled only one time? So it's a big number. 25 nodes, 25 string length, and it won't be possible to handle it. कॉम्बिनेशन की भी उसमें से मेरे को बेस्ट वाला सोल्यूशन ये चाहिए कि भाई जिसमें मिनिमम डिस्टेंस ट्रैवल करी जा सके. तो ये चलो ये आपको एक एग्जैक्ट सोल्यूशन दे देगा. अदरवाइज रियल लाइफ में देखूंगा अगर थोड़ा बहुत प्लस माइनस भी चलता है तो इट इज एक्सेप्टेबल. इट्स नॉट दैट बिग इशू फॉर ह्यूमन, बट विद दैट कंस्ट्रेंट अगर हम इसके वजह से फॉर्मूला की बात करें तो इट्स वेरी गोइंग टू बी वेरी कॉम्प्लेक्स. ऑल्दो इट्स लीनियर, पैरामीटर नंबर ज़्यादा है, लेकिन सॉल्व करना टीडियस काम होगा. लेकिन आर्टिफिशियल इंटेलिजेंस में एवोल्यूशनरी एल्गोरिथम जीए हैज गिवन दिस सॉल्यूशन इन अ वेरी इफेक्टिव टाइम, यू कैन से. Okay, this is how we handle our problems. Okay, any query till this time? फिटनेस फंक्शन, जैसे मैंने अभी आपको बताया कि इन दिस केस द फिटनेस फंक्शन इज द टोटल डिस्टेंस ट्रेवल्ड. You have nodes xy coordinate parameters are there. You can identify the distance between the two nodes. What is the total distance that is traveled by a traveling salesperson? It's all the addition of this all. In your case of own domain, you'll have to check that your application area, how you are going to evaluate that design. Let us say we design one engine. Obviously there are number of parameters into that. तो मैं इंजन की एफिशिएंसी की देखूंगा, माइलेज कितनी मिलेगी मेरे को से इंजन से, पावर कितनी मिलेगी, मल्टी पैरामीटर्स हो गए ना. तो अगर मैं दोनों को बेस्ट निकाल सकता हूँ कि माइलेज, देखिए नॉर्मली क्या होता है कि अगर मेरे को पावर ज़्यादा मिलेगी तो माइलेज नीचे चली जाती है. तो अगर मेरे को माइलेज भी ज़्यादा चाहिए और व्हाट डू यू से पावर भी ज़्यादा चाहिए और माइलेज भी दोनों ज़्यादा चाहिए, तो वो डिज़ाइन मेरा बेस्ट होगा. दैट इज विद टारगेट मल्टी ऑब्जेक्टिव प्रॉब्लम्स. आप सिंगल ऑब्जेक्टिव की बात करोगे भी मेरे को सिंगल ऑब्जेक्टिव चाहिए, मैं कार लेने जाता हूँ. ओके, तो कौन कौन से पैरामीटर का ध्यान रखता हूँ? देयर आर मेनी पैरामीटर. माइलेज है, बहुत इंपॉर्टेंट है, और फ्यूल टाइप क्या है, एवरेज जो उसकी लुक्स कैसी हैं, एक्सटीरियर लुक्स कैसी हैं, वेरी राइटली पॉइंटेड आउट कि सेफ्टी फीचर्स क्या हैं, एंड ऑब्वियसली द बिगर वन द कॉस्ट. देन वी ऑप्टिमाइज दैट, मेरे को मिनिमम कॉस्ट, मैक्सिमम फीचर्स, मैक्सिमम माइलेज, तो बहुत सारे पैरामीटर्स हैं यहाँ पे मेरे को जो ऑप्टिमाइज करके निकालने हैं. देन आई फाइनली टेक, फिर कलर की बात आती है. कलर के लिए तो हम यही बोल देते हैं, बच्चों को बोल देते हैं कि बताओ ये वाला रेड वाला है या ब्लू वाला है. तो these are all parameters that we want to optimize, okay, based on various parameters, input parameters are there. Okay, this is obviously this is fitness function is always application specific, domain specific. We cannot make it generic. हाँ, कुछ ऐसे मैकेनिज्म है, जैसे अगर मैं कहूँ कि मेरे को टारगेट डेटा मिल गया कि ये मेरे को अचीव करना है और मैं आउटपुट कैलकुलेट कर सकता हूँ, Okay, let's say कि I have a list of output values corresponding to some inputs. ये मेरे को इनपुट देने पे ये आउटपुट मिलनी चाहिए, ये इनपुट देता हूँ ये आउटपुट. आई कैन हैव ट्रेनिंग डेटा यू कैन टॉक ऑफ कि भी इनपुट दी आउटपुट ये आनी चाहिए, लेकिन नहीं आई, सिस्टम ने ये दी, तो वहां पे आपके पास जो आनी चाहिए थी जो आई, दोनों के बीच में एरर होगा, डिफरेंस होगा ना. अगर वो डिफरेंस जीरो हो गया इट मींस कि यू हैव डन योर थिंग. लेकिन ऐसा नहीं होता इनिशियल स्टेज में, रैंडमली जब हम स्टार्ट करते हैं तो डिफरेंस को हमने मिनिमाइज करना है. वो डिफरेंस ही आपका ऑब्जेक्टिव फंक्शन बन जाएगा उस केस में. Isn't so? वो स्ट्रेट फॉरवर्ड सी एप्लीकेशन बन जाती है जिसमें हम आरएमएससी की बात कर लेते हैं, या मीन स्क्वायर एरर की बात कर लेते हैं, या एब्सोल्यूट एरर की बात कर लेते हैं. दैट इज वे. वो एक ऐसा एल्गोरिथम है, एक ऐसी अप्रोच है, वो काफी एप्लीकेशन में फिट हो जाती है, बट हमेशा हो गए इसकी कोई गारंटी नहीं है. देयर इज नो हार्ड एंड फास्ट रूल, नो थंब रूल दैट this will be applicable all the time. Yes, any other query? Sorry? Yeah. Yeah, it is. Actually, we want to make maximum exploitation. Actually, there is some investigation studies into that also. In initial stage, we make exploitation maximum. Once that saturates, result is not improving, then we start exploring. Mutation is increased. Mutation is increased. I have experimented with BBO where we have made mutation 50% and resulted in very good performance. Overall result was very good. Starting case, we were having exploitation more, migration of species from one place to another, or using crossover is maximum starting. Once that is सैचुरेटेड समटाइम कि इसके बाद में इंप्रूवमेंट नहीं हो रहा, देन क्रॉसओवर की जगह पे, क्रॉसओवर को हमने उतना ही रहने दिया, म्यूटेशन बढ़ा दिया. दिस रिजल्टेड इन वेरी गुड रिजल्ट गिविंग मी. और एकदम से नए आपके पास फीचर्स ऐड होनी शुरू होगी जो पहले आपके पास एग्जिस्ट नहीं करती थी. एक्चुअली वंस अगेन इट्स अ स्ट्रेटेजी पैरामीटर दैट इज स्पेसिफिक टू योर प्रॉब्लम. You have to experiment while you are solving some problem. You'll have to experiment that कि which value of mutation is most suitable to your initial experiment to give you an idea that what should be the mutation rate. I was also having that idea that in biogeography there is very similarity into that, but it is one directional. Biogeography में यहाँ पे crossover में two directional फीचर एक्सचेंज है. बायोजियोग्राफी में वन डायरेक्शनल है, मैक्सिमम फिट से मिनिमम फिट की तरफ ही फीचर्स कॉपी होती हैं, अदरवाइज इट इज सिमिलर. आफ्टर सम टाइम इट बिकम सिमिलर, सारी पॉपुलेशन एक जैसी बन गई, कॉपी हो करके आफ्टर 1000 आइटरेशन वो सारी की सारी पॉपुलेशन एक जैसी बन जाएगी. तो उसको अवॉइड करने का यही तरीका था कि आप मैक्सिमम उसमें म्यूटेशन डाल दो. दैट रिजल्टेड इन wonderful results. One Yagiuda and Tina were designed using this algorithm. Okay, any other query? Mutation parameter, crossover parameter, approximate values are given like this, that keep more than 95 crossover and less than 5% for mutation. But it is not hard and fast rule. There is no hard and fast rule. This is the most of the result जो हमारे के इन्वेस्टिगेशन से मिले हैं, उन्होंने अच्छा परफॉर्म किया है इस तरह के पैरामीटर पर. इन आर्टिफिशियल इंटेलिजेंस डोंट टेक एनीथिंग हार्ड एंड बाउंड, है ना, ये ऐसा ही करना है, नहीं. म्यूटेशन देखिए एक सिंपल सा है कि अगर म्यूटेशन आपने 100% कर दी मींस दैट इज अ रैंडम सर्च. you'll have to take care of that idea also that it should not be a random search. ऐसा नहीं हो कि तुक्के मारने शुरू कर दिए. there should be some logic for that also, that a crossover is also going to contribute. अगर if you increase the mutation to 100% then crossover concept is lost. You'll have to take care of this. Okay. next is about okay, bird flock. Huh? This is about particle swarm optimization. I think you might have seen this type of scenario.
Sir, good morning, sir.
Morning, good morning.
Sir, this is from Modi University, Dr. Sudhir Y. Kumar.
Ji.
Sir, I would like to ask you one question
Yes,
uh,
please.
on this optimization.
Mhm.
Sir, is there any minimum, this is any specific condition why we do that minimum objective function for a particular application? There is any specific
I'm sorry, why?
minimum or maximum objective function is to be
Okay.
taken care?
Okay, I have discussed one example of profit making problem. I think we'll be taking it as a maximization problem. Huh?
Yes,
If
sir.
you want to consider minimization problem, say error minimization is one scenario, you can make it a maximization problem. One upon error, it's a maximization problem. Are you getting point? If you make it fitness function equal to 1 upon error,
Yes.
yeah, 1 upon 1 plus error, RMSE you can talk of.
Yes, sir.
This will become a maximization problem.
Mhm.
Okay, so there is no hard and fast rule that you will be dealing with all minimization problems or maximization problem.
Mhm.
You can modify uh, any problem into minimization or maximization problem.
Okay. So in general, sir, what are the different types of objective function? Hello?
Hanji. Broadly saying, there are single objective and multi-objective. This is one way of classification.
Okay.
The another way that depends upon your application, that it is maybe formula based or maybe data based.
Mhm.
You can design your optimization function that may be derived from data or it
Mhm.
may be derived from formula.
Okay. Thank you. Thank you.
Good morning, sir.
Good morning.
This is Pramod Bhatt from Modi University. Sir, out of the mentioned algorithms, I want to know whether the genetic algorithm is suitable for adaptable system. I mean, I'm working on the smart grid system where the parameters are online coming. So, is the genetic algorithm suitable to optimize the system on the online basis and adaptable also? To
Okay,
adapt
you
adapt
want
the
it to be
parameters.
online supervise, online optimization.
Yes.
Are you talking of on real-time optimization?
Yes, sir. Real-time parameters are coming, and
Okay.
simultaneously, I am getting the optimized results. Is
Mm-hmm.
like optimal power flow analysis.
Mm-hmm. Got it. Okay. There are some problems where we need to optimize our decision after every iteration. Uh, let's say that this scenario of ad hoc networks. Also, I want to transfer my data from one node to another node. These nodes are also moving. Then this type of scenario is demanding optimization of the path in real time. Most of the time we have applications, those are offline applications where I have to decide only one path one time, and that is to be done at the very initial stage. Then we just make use of that solution. But this is the scenario that is possible. GA can solve this problem, but one has to be very careful that all the number of iteration has to be limited to some specific small number, so that all these iteration can be completed in time and you will be getting some results. Your fitness function should be in such a way, it should be designed in a way that computationally should not be very intensive. Let us say RMSE is there, and if RMSE is going to be calculated for 1 lakh error differences, then it will take a lot of time. If it is some tens of numbers that whose error is to be calculated, then it's okay. It can be done on real life.
Solve the GA and PSO equals faster. It gives the result faster than GA.
GA is actually algorithm. Most of the things are algorithmic. PSO is having two equations that is formula based. That's why in this discussion I talked about that we most of the time look for algorithm. Those are mathematics, some background for that. We try to formulate some mathematical formula for the inner functions of the biological, the logics, whatever we are falling into. But it is not always possible. But wherever it is possible, just like PSO, it is possible with that PSO that you can have calculation based on some mathematics, and it is done faster with the computer also. Wherever we need algorithm, it is done bit slower. You'll have to take care of your application if you are working on real life application. Be careful about that. Calculation should not take a lot of time. Iteration should be limited. Am I clear?
Thank you, sir.